Hello guys, hope you are doing well. So today we are going to discuss the lead code problem under backtracking tag. So I have already discussed the problem 1 to 5. So today we will going to discuss the problem number 6, permutations. So let's jump into the problem. So this problem is given a collection of distinct integers. So integers are distinct and we have to return all possible permutations. So you as we already know that if there are n distinct number, then total number of permutations are going to be n factorial. So here we have to print all those permutations. So how we are going to do, like, how we are going to print all those permutations, or how we are going to return all those permutations? So we know that in in generating permutation, we each element of the this array is going to swap its position with all the elements, and recursively after swapping position, then in the next state all the remaining elements are going to swap its position. So you can say, like, one is going to swap the position with 2, and one is going to swap position with 3, and one is going to swap position with itself actually. So after swapping with its position with 2, and then the element at index like 1 is also going to swap its position with all the elements that are right to it actually. So we are going to use that approach, and this is the classical example of backtracking. So we have to, like, after swapping its position, so and then we have to backtrack this as well, because the swapping effect of one element should not affect the others actually in the different call. So we have to backtrack those changes as well. So let's jump into the code. So, and let's we have to return this combination, like, all this is the list of permutations. So let's name it answer equal to new array list, new array list, and we have to add list of integers. So we'll add these numbers into the list. So for int x nums num dot add x. So we are going to solve this. So we will start with the index number 0 and this link array list, and after that we'll return the answer. So now we have to write this solve function. Int idx list integer, let's name it candidate. So we'll know that if we have exhausted all the elements, like if idx is equal to candidate dot size, then we know that we have added all the elements in our candidate, and the current candidate is a potential candidate of a permutation. So we'll simply need to add it into our answer by creating a copy of it, and simply return. Otherwise what we will do, like, we will try to swap the element at current position with all the elements to its right. So we will do that here. So for int, let's say I equal to idx I is less than can dot size I plus plus. So we'll swap collections. So we're going to swap collections dot swap candidate. So we are going to swap the current element with the ith element. Okay, and then we are going to solve it for the remaining elements after swapping. So we'll need to call it like solid. So it is going to be like idx plus 1 and candidate, and after that we have to revert dot revert that swap. So candidate idx I. So in this way we can swap it. So let's run this. So yeah, it is working fine. Let's try to submit it. Yeah, so it is working perfectly fine and it is accepted. So hope you have enjoyed this video of generating permutations, and we will discuss like permutation 2, where each element might be occurs in more than each element might occur in more than once actually. So there are multiple occurrences of a particular element. So how we will handle that, we will discuss in the next video, permutation 2. So for more video like that, do subscribe my channel. Thank you for watching.